Hey guys, in this video we'll learn how to balance redox reactions in acidic conditions. There are 7 steps to this, and the first step is to write 2 half equations. One will be a reduction, and the other will undergo oxidation. The second step is to balance everything except for oxygen or hydrogen. Third step, add water to balance the oxygen. Fourth step, add hydrogen ions to balance the hydrogen. Add electrons to balance charge in both half equations. Then they add equations together, then simplify. So let's start off with an example. And here is a basic reaction here. Okay? And we want to balance this. So our first step was to split this into half equations. I like to draw a line down the middle and work with 2 half equations at the same time. Yeah, so our half equation would be Cl minus produces Cl2. You don't need any electrons on this, we'll do that later. Okay. And MnO4 minus produces Mn2 plus. So that is our first step completed. And our second step is to balance everything except for oxygen. So basically what that means is that we want to balance the number of atoms of chlorine on the left hand side with the number of atoms of chlorine on the right hand side. You can see how there are 2 atoms of chlorine on this side and 1 on this side, so we need to multiply the left hand side by 2 to balance the chlorine out. So we end up with 2Cl minus produces Cl2. For MnO4, you need to balance the manganese. But you can see how there's 1 manganese on the left hand side and 1 on the right hand side, so you don't need to do anything for that. Okay, our second step now, or I should say third step, is to balance the number of oxygens on both sides. This is not applicable to our first half equation because there's no oxygen in it, but for our second half equation we can see how there's 4 oxygen atoms on the left side. And to balance this, we need to add water molecules to either side of the equation to balance the number of oxygen out. Just recalling, water is H2O, so there's one oxygen atom per water molecule. So if you want 4 more oxygen atoms on the right hand side, you must add 4 water molecules. So there's 4 oxygen and 4 water molecules. That's all you have to do for step 3. Now for step 4, we need to balance the number of hydrogen atoms. There's still no hydrogen on the first half equation, so let's go to the second one. We can say, for the second one, we can see how, since we added a water molecule, or 4 more water molecules to the right hand side, we now ended up with 8 hydrogen on the right hand side, and there's none on the left hand side. So to balance this out, we need to add 8 more hydrogen to the left hand side, and we do this by just adding a hydrogen, by adding 8 hydrogen ions to the left hand side. This is because this is in acidic conditions, and the acidity of a solution is determined by the concentration of hydrogen ions, which is why we can just freely add hydrogen ions to the equation. Okay, so now the hydrogen atoms and the oxygen atoms are balanced out. Let's move on to our second step, to our fifth step. Our fifth step is to balance the charges out. And to balance the charges out, you need to look at the charges on the elements. So your chlorine is -1, and we have 2 of those. So the charge on the left-hand side is -2. And that's a diatomic molecule of chlorine. The charge is 0, so it's not balanced. To balance this, we need to add some negative charges on either the left-hand side or the right-hand side. So we're going to add electrons. To balance this, we need to add 2 electrons to the right-hand side. So the equation now becomes that. So we added 2 electrons to make the charge of the right hand side equal to -2. Now for our second half equation, this is where we need to be careful. So I would recommend writing this down in a different color. So there's 8 positive charges from the 8 hydrogen ions, and there's 1 negative charge. So that will be -1 from that, because the charge is the valency. Okay, so the charge on the left hand side is +7. Now on the right hand side we already have a 2+, and water is neutral. Okay, so the charge of the right hand side is +2. So we need to take 5 off 7 to produce 2, which means we need to add 5 electrons to the left hand side. So the equation now becomes MnO4 minus plus 8H plus minus the plus 5E minus produces Mn2 plus 4H2O. And our next step is to balance the number of electrons in both equations. So we can see how in our first half equation we have 2 electrons, but in our second one we have 5. And later on we want to combine these 2 equations, and the only way to do that is if they have the same number of electrons. So we need to find the lowest common multiple of 2 and 5. And you should know this by now. The lowest common multiple is 2 times 5, which is 10. Yeah. So we want the number of electrons for both of the half equations to equal 10. And to get to 10 from 2, we times by 5. So we need to times the whole equation by 5. So we end up with 10Cl minus produces 5Cl2 plus 10E minus. And to get to 10 from 5, we need to times by 2. So this becomes 2MnO4 minus plus 16H plus 10E minus produces 2Mn2 plus 8H2O. And our second last step is to combine these 2 half equations together. So we end up with, let's write it in red, we get 10Cl minus plus, so we add this to this, the left hand side to the left hand side. So we get 2MnO4 minus plus 16H plus 10E minus, let's go down a bit. We get 5Cl2 plus 10E minus plus 2Mn2 plus 8H2O. Now here's the fun time. You get to cancel things out. So it's like a math equation where if you have 8 equals 2 plus 6, you can move the 6 to this side or subtract 6 from both sides. So you get 2 equals -4. This is obviously not true, just an example that you can move stuff over. Yep. So basically, you see how we have 10 electrons on both sides, so we can cancel them out. It's like subtracting 10 from both sides. So now we have nothing else that we can cancel out. So write a final statement. Therefore, the fully balanced equation of this is 10Cl minus plus 2MnO4 minus plus 16H plus produces 5Cl2 plus 2Mn2 plus 8H2O. And that was how you balance balanced complex redox reactions using half equations in acidic conditions only. If it wasn't in acidic conditions, you wouldn't add hydrogen ions, but you would add hydroxide ions, just OH minus. But that's for another video.